everyone, we're going to graph the rational function y equals x minus 3 divided by x minus 2. This is more of an introduction type video, as if you have never graphed these before. So we're going to go a little bit slower. Usually rational functions, when you graph them, look something like this. Or the other way. This is if you have 2 branches. It might look something like that. This one doesn't have 3 branches, so I'll just skip that part. And what we do is we use asymptotes, that are lines, to frame our graph. So we're going to graph the asymptotes, and then we'll plot a few points to help us finish the graph. And the first thing, our asymptotes that we have are the vertical asymptotes and the horizontal asymptotes. Vertical asymptote is easier. It's merely where your denominator cannot equal 0, because dividing by 0 is undefined. So solving for x, we have x cannot equal 2. Well, that means that's your vertical asymptote. So x equals 2. Because it can't, the graph cannot cross this line. Again, remember, asymptotes are lines. The horizontal asymptote's a little more conceptual. So basically what it's saying is, as x increases, as x gets larger and larger, what does my y value end up getting closer and closer to? So let's look. If I plug in, say, 100, I'm going to get 97 divided by 98. Well, that's very, very close to 1. So probably our B is 1. And if you have a hard time with that, it's a good idea to plug in a really large number. So if I plug in, say, 1,000, I would have 997 divided by 998. And that definitely is closer to 1. If you plugged in 1,000,000, it gets closer and closer to 1. So that means your B value, or your y, equals 1 is your horizontal asymptote. Now all we have to do is plot these 2 lines, and then we're going to pick a few points to get an idea of the graph. So let's plug in x equals 2. And also y equals 1. It's like a translation of the axis. All right. Now that you have that, we know that this is 2 right here, this point here. This is 1. And what I want to know is what's going on the right-hand side of 2, or when x is bigger than 2. And also I want to know what's going on when x is smaller than 2. So I can get a general idea of what this graph looks like. So if I plug in 3 into my equation, I'm going to get 3 minus 3 divided by 1. Well, that equals 0. So at 3, we're at 0. That means my graph's going to be below the y equals 1 line. Now let's, you can plug a number in here, but let's plug in, let's say 6. Let's plug in 6. So that's 3, 4, 5, 6. If I plug in 6, I'm going to get 3 divided by 4, 3/4. So that gets closer and closer to 1. If you plug a number in here, in between, it's going to get down in here. So the graph looks like this. It doesn't cross there. All right. Now, we're going to see what's going on the left-hand side of 2. So let's plug in 1. If I plug in 1, I get 1 minus 3 divided by 1 minus 2. That gives me negative 2 divided by negative 1 is 2. So at 1, we're at 2. So there it is right there. All right? So you're going to see that this is going to be symmetric here. Now let's plug in, let's just pick -6. Let's do that. So it's, let's plug in 0. If we plug in 0, we get -3 divided by -2, which is 1.5. So at 0, it's 1.5. Right about there. And let's plug in a bigger number. Let's plug in 6, -6. You get -6 minus 3 is -9. Divide it by -6 minus 2 is -8. So that's 1.5. So it's getting closer and closer. What did I plug in? -6? 1, 2, 3, 4, 5, 6. Gets closer and closer to the asymptote here. It's always a good idea to plug a number in here, but that's going to involve a fraction. And we want to have this symmetric to the line that we already drew. So our branches get closer and closer to the asymptotes without crossing. And that's how your graph would be. Thank you. Have a nice day. Bye-bye.